During the next talk is by Ulrike Fischer. I'm not sure if it's necessary to introduce her, but for the sake of completeness, I would like to introduce her. So she's one of the, in Japan we would say kami-sama, one of the gods of Stack Exchange and other answer sites, giving always extremely helpful answers to the most involved questions. So it's not surprising she has also been a member of the core LaTeX team since a few years now. We have also asked her to grant her service to the TUG board. So since I think last year, is it right? Since last year, Ulrike is also a member of the TUG board, where she actively helps to further the development of tech. And I'm looking forward to her talk. So Ulrike, I will play the video from here. Anyone, if there's a problem with the sound, please let me know. I route it through, it should work. If not, just chat or what.
Hello everybody. Welcome to my talk about how to use spot colors in LaTeX. Spot colors come up when we made the LaTeX companion ready for print. The LaTeX companion will be printed in two base colors, black and Pantone, that's a type of blue. And the tasks were to use the colors where needed and to remove all other colors from the document. The first task was to hunt down the color uses. Colors are used in many places, for example for text, in heading, side notes and examples, page decorations like the page number, the crop marks. There are color boxes with shadings. There are examples with font specs color key. There are examples with to-do notes, which use often ticks in the background too. There are directly examples with ticks. Colors are also used in various forms, not only as pure colors, but also are mixed, black and the spot color. And there are naturally also color mixes in various packages. For example, in the TixLinks package, the eye of the mouse is a mix between the body color and black. To check if everything is right, you can, for example, use Adobe. It has a dialog which shows you the color plates, and you can then deselect a color. For example, if you now remove the Pantone color, which is here, then only the black remains, and if we now remove the black, then nothing remains, and that is good because it means that we don't have stray colors in the document. What are the spot colors, the Pantone color used in the document? A spot color is a special color model. PDF calls this a color space, but this is only a different word for the same thing. Such a model is similar to the RGB or CMYK color. It describes an ink to use. It has only one value, not 3 or 4 like RGB or CMYK, and this one number gives the amount of the ink to use and is called the tint. Typically, a spot color model also gives a fallback for devices who don't know the ink, like the screen. The fallback is typically CMYK, but other color models are possible here too. In the PDF, such a spot color is quite easily defined. It's a not very large object. It is of type separation. That's a special name for this type of color. Then it gives the name of the ink and a fallback function. So here is, for example, CMYK, and here below are the values for the CMYK fallback. In the PDF, you need also to define a name to map the spot color. And in this case, we use the name color 1, which maps simply this name to the object number that we have set up before. This mapping is done in the page resources of the PDF. After these two setups, we can use the color model. There's a special operator for this, CS, which gets as value the name we have defined before. And there's another operator, SCN, which gets the value that we want to set up. There are two variants, lowercase and uppercase. The one is for the fill color, and the other is for the stroke color. To set up such a separation or a spot color, you can simply use code that is already in LaTeX with kernel methods. Such a separation needs to set up PDF objects and write to the page resources. Therefore, it needs a new PDF management. This is loaded with the document metadata command. When you have loaded it, you can now set up a new separation or spot color model with the command color model U, which takes 3 arguments. At the first is some name that we want to give to the model. I choose here Pantone 3005. Then you give the type in this case of the model. In this case, we have a separation model. And then the last argument is a key value argument where you give the name of the ink and you describe the fallback, the model of the fallback and the values of the fallback. After you have done this, you can define colors with the color set command. In this case, we define 2 colors, spot A and spot B, which differ only in the tint we give them. And they are used now on a new model which we have defined before. To use a spot color, you only need to select it. To ease the examples, I defined first an alias for the exploit command color select, which I will call color select, but you could use whatever name you want here. If you select our color, spot A and spot B, then we get something like here below. So spot A is a bit darker as it has a higher ink tint, and here we see what is in the PDF. You can see that our color model has been selected with the value 1, and the second color is a bit lighter, and he used also our color model but a bit with a 0.5 as value. We want to mix our colors. That's quite normal. Mixing with white is quite straightforward. White simply changes the tint, and this is what you actually want. But you must pay attention regarding the orders. You should always start with a spot color in a mix. So here we use our selection command, and then we mix spot A with white, and here below I do it wrong and start with a white command, white color, and let's look what happens. The spot A is now, the mix has a smaller value and is a bit lighter, but if you start with a white command, nothing changes, so you can see that this is wrong. Mixing with black is more difficult. When you mix with black, you actually want to add an ink. You don't want to change simply the tint. Simply using again the normal mixing command doesn't give the correct result. If we do this, we can see that spot A simply doesn't change at all because it has already tint 1 and higher is not possible. Spot B gets a bit more darker as it had more tint, but this is not what we want. We want more black. We don't want only more tint. And if we look this in the check dialog again and remove our Pantone color, then we can see that everything disappears and there is no black at all. The right way to mix black into the Pantone color is to create a new color model, a so-called device N model. Device N is again a rather simple object in the PDF. It has device N and then it has an arrow which contains the two components, the Pantone color and the black color. Similar to the separation model, it describes a fallback, which I don't show the details here, but it's quite similar, a simple function which maps the two the values to the CMYK. Again, we have to define a name that we can use to call the color model. In the color space, in this case, it's now color 2. And then, once we have set up this, we can call the color. Again, we use a CS operator to select the color model. And now we have to give two values because we have two components. The first value describes how much of Pantone should be used, and the second how much of the black should be used. The setup of such a color model is again quite easy. We can simply use the color model new command. We choose some arbitrary name, and then this time we use as type device N, and the third argument simply takes the names of the two components. We refer here to our previously defined separation color model and to black. Once we have done this, we can use the colors. We can again define colors. I define here 3 different colors. One mix, which directly use a bit of Pantone and a bit of black. Then I define a pure Pantone, which use only Pantone, and a pure black, which use only black. So these two colors looks a bit senseless, but defining such orthogonal colors allows us to mix them again with the X-color syntax that you are used to. That's quite neat. Let's look how to use them. I select the mix color, I select the pure Pantone color, and I select also a mixture between the Pantone and the pure black color. And if you look at the result, you can see that the mix is a bit darker, and it has now, it uses our second color model with values half Pantone, half black. The pure Pantone use only Pantone and no black, and the mix use again our device N color model and mixes the color. We can again check in the dialog of the Adobe. If we now remove from this only the Pantone color, we can see that some black remains. That is what we wanted by mixing in the black ink. The kernel command has a nice feature that we can define a color to use more than one model. Here above I redefine the black to use two models. At first CMYK and at second Pantone, and black our device N model. And here I give some values for the CMYK model, and here I give the values for our Pantone and black model. A color that is defined like this can be used in various contexts. If I use it only in itself, it will give a CMYK color, but if I mix it into the pure Pantone, it will behave as if it is a device N color. You can look again at the result. only using black gives us CMYK. This is a syntax PDF uses for CMYK colors. This and the mix uses our device N and color model and mixes the two. But again, pay attention to the order. If we start with this black, then we get a CMYK color, because black has as main color model CMYK, and this model then wins. This is a wrong result and something that we actually don't want, because it means that we have cyan and yellow in our document. Up to now we have only set both the fill and the stroke color to the same value. That is normally what you want if you color text, but it's not what you want if you do graphics. Graphics often want to set them to different values. This can be done with the kernel methods. As an example, I show here how to do it when using the Eldor Draw package, which is part of the Eldor experimental package bundle. We have here a simple picture which starts with draw begin and ends with draw end. We set the line width to something that one can see in the presentation. Then I move here a path and I close this path. And then I set the two colors. I set the fill color to our spot R color, and I set the stroke color to our mix color. And at last I draw the path. That I tell them that it should both stroke and fill the path. Then we get this triangle where the fill color is spot R and the draw color or the stroke color is our mix color, a bit darker. Spot colors with font spec. One example in the companion set showed how to set the font color. Sadly, we realized that this color is RGB. This is rather fixed inside font spec, and what was what we want. So we had to update Lua OTF load, and from now on it is possible to use spot colors as defined with the kernel models that we have created before in the optional argument, and so to color the font. This requires Lua LaTeX, and it requires a rather current LaTeX system as it is very new. Summary of the kernel methods. They work fine with text. You have to need attention regarding the order and definitions if you mix colors. The definitions know multi-models. They can handle fill and stroke color separately. They work with font spec. If Lua LaTeX is used, C LaTeX will not work, but they don't support TIGs, or the other way around, TIGs doesn't support the kernel methods. So what do we do about pictures, the color boxes, to-do notes, etc., which all use TIGs in the background? So we looked for the alternatives. The other package related here is the color space package from Javier Bezas. This package patches into Xcolor, which allows to use it also to some extent in text, but it works only with PDF LaTeX and Lua LaTeX, not with other engines like the kernel methods. With the color space package, setting up a spot color is quite similar. It's a bit shorter. The main command defines the separation model or the spot color model in the actual color in one step with a defined spot color command, which takes the name of the color name and color model names in one, and the ink and the last argument is the fallback that you need for the fallback value. Using the color can then be done simply with a standard color command as color space patches into X color. And you get then something quite similar in the PDF as previously, only that the name used for the color model looks a bit more complicated, as it doesn't use simply a numbered name, but builds the name from the ink name. And the order is a bit different. Here are the values, but this doesn't matter. You can set up also device N models with color space. In this case, you have to use two commands. At first, you define the color model itself. Again, has 3 arguments. The name of the model, the keyword mixed, so that you know that you are creating a device N model, and the components at the end. Once you have defined the model, you can define colors with a define color command, which simply use as model the model that we have defined before, and gives the color names. And again, it's quite useful to create orthogonal colors so that you can use normal mixing commands later, or mix expressions. Color pure Pantone and pure black will then do the same as it did in our previous example. Mix image colors works more or less similar to the kernel method, only it errors more often if you do something wrong. If you want mix with white, it simply changes the tint as previously. If you change the order and start with white, you get an error. It will simply complain that and not try to fall back to something. If you mix with black, you will get an error too, as black is either RGB or CMYK, depending on your document, and cannot be mixed into a spot color. Color space doesn't support multi-models. You cannot define black to be both either CMYK and device N model. So you have really to define two different names to distinguish these cases. The color space errors are sometimes a blessing because they help you to find wrong mixes. Sometimes they are really a problem, as many packages use such mix expressions a lot, and hunting down where now again it had errors is not always nice. Sometimes you simply would want that it does something that is more or less okay and don't really care about perfection. It's I wasn't sure what sometimes I cursed and sometimes I said, oh nice, it told me I had overlooked something. Color space has a number of bugs that we found while working with it. One problematic color bug is that if you map a spot color to the current color represented by the dot, and then the current color to some other color, you suddenly end up in the PDF with a color model of 0, 2 zeros here. This is wrong. This really breaks the PDF. Adobe will complain and not show any picture. So a similar error is made if you use a colorlet command together with the optional argument named. Then you get a similar 0 suddenly in the PDF. Both is a problem because this type of letting colors to each other are used a lot by TIGs, and so really some of the TIGs pictures were broken. We had to patch X color space here in various places to get it working. Summary of color space. It also provides separation in device N color models. It hooks into X color. That's quite nice because it means that you can use the standard color command and color definition of X color typically will work. It works more or less good with TUG because it uses X color. It errors with unknown mixes. The drawbacks is that it doesn't support all backends. It's not such a problem for the companion, but could be for other documents. It doesn't support font specs, font colors, the color key of font spec. It doesn't support multi-model colors, which is more a problem if you start really to mix around with separation device N and CMYK, then being able to define one color with more than one model is quite useful. It errors with unknown mixes, which can be a pain sometimes. It has a number of bugs, so if you want to use it, you have to pay attention that you didn't get a broken PDF. It doesn't have real support for stroke and fill colors. You can't set them separately. And it works only more or less with TUG, mostly because of the missing support for stroke and fill colors. This last problem is actually not really a problem of color space. The underlying problem is here that neither the color nor the X color package actually support access and setting of separate fill and stroke colors. If you look at the internal representation they use for the colors, you can see that the color package, for example, stores the color simply as a backend instruction, which contains both the fill and the stroke color together. X color representation is similar. It has a bit more arguments, but here too the main argument stores the fill and stroke color together. This is a problem for TUG because TUG has to be able to set a stroke or a fill color on its own. To do this, TUG around works with a number of low-level code and own backend code, and this makes it quite difficult for a package like ColorSpace to inject proper spot color support. It would be also difficult for the kernel methods. Really, there is something amiss here, and this makes spot color support currently not easy. Special TUG problems. We had some shadings in the document. Shadings are not simply some color that it's drawn on the page. There are rather special objects stored in the PDF. By default, the TUG shadings use all RGB. If you look in the PDF, you find somewhere typically such a shading object, and then somewhere there is the device N RGB instruction, which means this shading is RGB. Some time ago, David Purton added support for CMYK shadings, and so when you use it for enforce CMYK color model, then you get shadings which use CMYK. But there is no support for spot color shadings, and writing the code to support them would have too much work, so we used only grayscale shadings in the companion and didn't leave. Perhaps sometime someone is found who could extend the support to also allow spot colors. Another problem are patterns. Patterns, this here below, something like this is a pattern, and here is a shading. A pattern is also a special object in the PDF. patterns in TIGs are also RGB. This is rather low-level code and cannot be easily changed. TIGs creates in the color space resources something like this. So a keyword to call the pattern, and then it tells that it's a RGB pattern. This is also the case even if the pattern is black and white. It's not gray then, but it is also RGB. We could manage to make a CMYK pattern by some patches. We added to the resources a keyword for a CMYK pattern, and then we patched the underlying low-level code, which adds the code to the PDF and forced it to use our new pattern definition to get black and white. But this was only for one pattern, and for a real solution would need some text changes. There is no support for colored patterns. These are simply still RGB. This finished my overview about the spot colors in LaTeX. I thank you for your attention. I naturally hope that next year some of the findings we found missing that are currently missing will be corrected, and that TIGs will be able to use the kernel methods to properly use spot colors in more places than now.
Yeah, Ursula, thanks a lot for the very interesting presentation. We have ample time for discussion, questions, comments, suggestions. So if you want to ask a question, either put it in the QA or raise your hand so that I can unmute you. Well, I have not a question, just a comment. I'm really happy to see more support for different color spaces and spot colors, because I remember that in old times when I had to prepare posters for it's old time, I have to say, posters for conferences, and back then the print shops were not RGB, but you needed CMYK and all this kind of stuff. So that was the time when I couldn't use LaTeX or whatever tech-based stuff, and had to use even worse things. So I'm quite happy to see a lot of progress here.
I hope to get better. I think we should be able to.
Ulrike, we don't. Can you put up your volume a bit? It's very hard to hear you.
I should only put my mic.
That's much better.
Sorry. Yes, I hope that we will improve the situation here, also in TIGs, and it should be possible. Now that we have the implementation in the L2 layer, it should actually be possible for others to use them. Yes.
Yeah, I think in TIGs that would be actually a huge step forward, because TIGs has turned out as one of the main tools to draw graphics and all kind of stuff. And greatly appreciated. I see. Kaveh, go ahead.
Thank you very much, Kaveh from River Valley Technologies. I'm sorry for the very late hand up. I second that it would be great to have TIGs support, because TIGs is superb. Thank you for your work. The question I was going to ask now, there was you just a very, I don't know if I missed something. You said there the support for separate fill and stroke was not there. Can you, without going don't make too much time, I missed that bit. What's the problem with having separate fill and stroke?
The problem is that TIGs use Xcolor, and TIGs needs to be able to set the fill and the stroke color separately. But Xcolor doesn't provide this data, and so TIGs goes a bit around and recalculates the colors in various places. So it takes the 3 and 4th argument and tries to find out how the backend command for the fill and stroke is separately. This workaround makes it difficult to simply change to another color system. So it's coding. It should actually be possible if Joseph gives me a command to test if a color expression is a color. It could be possible to change this in TIGs, but it's need a bit testing. So, but I look at it. But
thank you very
TIGs
much.
has actually TIGs should have, when it started to use Xcolor, Xcolor should have extended its model to another argument. Then I think everything would have been much easier. But so it took what it had and a bit difficult. There's a question in the Q&R.
Yes, Manfred asked, can shading and pattern be generated for TIGs or need to be redesigned due to performance issues?
No, performance is not really the problem. The problem is that TIGs actually simply assumes only RGB is useful in various places. There's a same recount support in some places, but actually you should simply write the code so that it doesn't assume that RGB is wanted, but allows to exchange the color model. Performance shouldn't be a problem. It's mostly that the code has in some places put fixed RGB into when not really needed. I think shading's perhaps a bit more complicated, but I think if one looks at it and had some time, it should be possible to use another color model there too.
Sorry, this is Kaveh again, if I can just jump in. On the RGB, the restriction with RGB, how about having RGB and right at the end, if you want to print something to CMYK, use just another tool to like Adobe tool or whatever to output CMYK.
Well, sure, but we are LaTeX. We want to do it ourselves.
Correct. Yes. So that would be a dirty workaround. Correct.
Yeah. We want to get it right.
Correct.
And show that we can do it right.
Correct.
So there is another question in the Q&A from Dennis. Couldn't the wrong order issue be automatically corrected?
Well, the problem is that wrong order is not really right. The real expression. The kernel commands have to decide which color model is wanted as target, and it does it by looking at the first color. So if the first color is a spot color, it tries to create a spot color. And if the first color is a CMYK, it tries to create CMYK. Difficult to see how it could do it differently. You have simply to know that if you start to mix colors from different models, you have to think a bit about what you really want to achieve and not mix simply freely without caring. So spot colors, it's not really trivial sometimes, yes, but it's also for production, and so a bit care, I think, is okay.
So we still have a bit of time for questions, comments, discussion, if you want to continue.
Yeah.
I don't see anything. Well, then thanks a lot, Ulrike, for the very nice talk and all your work and in various areas. This is very much appreciated. And we're looking forward for your next talk next year, or maybe on other occasions.
Let's look what's happened.
So thanks a lot. We will start again in 3 minutes with the next talk on LaTeX. Thanks a lot.